Hi guys. Okay, let's start the section 7.1. Today we're going to talk about angles and then measure. Before we get to the first objective of the day, let's review some old concept, okay? So one of the concepts that I want to mention here is a ray. So what does it mean by a ray? It's like a line, but it's like half of a line in the sense that a line has no restriction on the two end. But for a line, we call it half of a line. But for a ray or half of a line, we have one restriction in the sense that you can have a vertex, a point. Okay, let me put it in red in here. So we start with a point here, we call it V for vertex. And then you can start in any direction that you want to. Say for this direction. And then we draw an arrow for like, you can extend the line to whenever you want to, like forever. Like you can draw it out of the page too. Or another line could be something like this. Okay. But the special thing about the ray is that you choose one direction and you go for it. Okay, you cannot like go forward and then backward and then forward and then backward, because if you do it, if you pass the vertex in the other direction that you go to, it would be a line rather than an array, right? Because you have like no restriction on two ends. While array, it has to have one restriction on one end, and the other end it has to be free. Okay, so that's enough about array or a half life, or I mean half line. Okay, so let me recall the xy coordinate. So back in the day, we learned about the xy system like this, where the horizontal axis will be x and the vertical axis will be y, right? And this axis in here, we're gonna have like 4 spaces. 1, 2, 3, 4. Okay, let me tell you the first rule you have to learn about trigonometry. We have 4 names for the 4. We have names for the 4 spaces in here. The spaces in here we call it quadrants. Okay, and I'm gonna show you how to number them. Okay, we're gonna start from the positive like measure of x and y. We call it quadrant 1, and after that we go counterclockwise. So this is counterclockwise. The next space we call it quadrant 2, and then quadrant 3, and quadrant 4. Okay, so now let's talk about the angle. What is an angle? So to create an angle, we first start with a vertex, and then we draw 2 rays. But since we have like one hand, so we can draw only like one ray at a time. So the very first ray that you draw, say like this ray right here, we call it the initial sign. And then the second ray that we draw, say right here, we call it the terminal sign. The name makes sense, right? Initial for the first one and terminal for the last one, right? And the gap in between, we call it an angle. Usually for angle in trigonometry, we denote it by theta. It's like a 0 and then slash in between. Okay, and the vertex, it could be anywhere on the xy coordinate, it can be anywhere on the paper, but if it were to be exactly at the origin, like this picture, we say that theta, the angle, is in the standard position. Standard because the vertex is at the origin. Okay, same thing goes in here. As we can see, the vertex in here is right at the origin. Okay, so every angle will have a measure, right? Like how wide the angle, like how wide the gaps between the 2 rays are. That tells you how much rotation you have for the angle. That would be the measurement or the measure of an angle. Okay, and all the angles will have a direction. For this one, let me backtrack a little bit so you guys can see the arrow on each of the angles in here. Alright, so for this angle in here, if you can see the little arrow on the red curve, it goes counterclockwise, right? It means that this angle in here is positive. While the other one, if you notice, the red curve in here, it goes clockwise. It means that the angle in here is negative. Okay, so make sure you know like the direction of the angle, and make sure you don't mistake between the positive direction and the negative direction. Okay, And the last information before we get to the very first objective of the day is the system of measurement. For angles, the most two common measure system for an angle are degree system and radian system. Personally, I convert everything to degrees because it's easier for me to deal with. At least I know that like I turn like a whole round here is like 360. That's like easier for me to understand. Radians is useful and it's really useful in a sense of technology. Like in a computer, most of computers and calculator they go by radians, but you know like it's decimal and it has to do with fractions, so it's kind of like you know like ugly a little bit, but they're great. Okay, and we're gonna talk about the relationship between degrees and radians in a minute. Okay, so now let's talk about more view. So in the very first example, I mean not even like count as an example, like this one is just like a warm up so that we remember how to draw an angle from, you know, like back in the day since when we learned geometry or something like that. Okay. So a quick cap like recall in here is that the gap from here to here is 90. The gap from here to here is 180 because it's tech out it because it's text up to like two spaces or like two quadrants, and the rotation from here to here all the way is 270, and if you go for a full round from here all the way back to itself is 360. You know, like you spin a round around yourself, it will be like 360 degrees, right? Like in English we say it's 360, but it's actually 360 degrees. We usually drop out the units. Okay, so let me take all that out and then let me use another color for this one. I don't know how to adjust it, but okay, here we go. Okay, so as a quick cap like recall for all the numbers I just told you, this one in here is 0 or like 360. I'm gonna write 360 when we get to it later, but this angle in here is 90 degrees. I write 90 because of the gap from here to here, like it stopped at here. From here to here we have a right angle. Usually we denote it by a square in here for right angle, right? It's 90. Let me take out that angle out, and then if you go all the way to the other side right here, it is 180 because it's a straight angle from here to here. Okay, and you go all the way down to here, it is 270 because we have 90 times 3. And lastly, if you go back to yourself, is 360 degrees. And just a heads up, make sure in the test, make sure in the quizzes, you draw out a little circle for degrees, okay? Don't drop out a unit because I'm going to mark you out for it. I'm going to take out some like partial credits for it. Say I'm going to take out like 1 or 2 points out of 10 points, okay? I'm really kept like strict with the units. I really hate to see the numbers without the units, okay? So the question here is asking us to draw 68 degrees. Okay, this is the bad color, so let me change it to, I don't know, like pink, maybe? Okay, this is better. 68 degrees. 68 degree in here is like a little bit less than 90, right? So 60 is around like 2/3 of 90. So I would say it's closer to 90 rather than 0. So I would say it's right here. We have a vertex, and then we have a ray, and then the gap or like the measure, the rotation from here to here, like positively counterclockwise is 68 degrees. Okay, for your work, for what you have to turn in, let me put it in I don't know, like green. You have to do this in here, this in here, and this in here. Okay, the other 3 figures, you have to draw the angle of 251 degrees, 333 degrees, and 98 degrees. Okay, so as like a quick recap of what I just told you guys, a right angle in here is 90 degrees, or pi over 2 radians. Let me write rad in here. Okay, people tend to drop out the word rad in the book. They don't write radian. That's why I don't copy the like radians in here, but in the test make sure you include it. Okay, a straight angle in here, it is 180 degrees, or pi radian. Okay, this is like the big part. This is the big relationship between the degree system and the radian system. Okay, we always have to remember that 180 degrees equals to pi radian. It's a really big thing that you have to remember throughout this course. Okay, and the last piece of information I want to recall you guys is that the circumference of a full circle, it is 360 or 2 pi radian. Okay, so now let's get to the very first objective of the day. Okay, for this objective, some of you guys might questioning like, what does it mean by optional? Whenever you see the word optional in my notes, it means that you're not going to be tested on this objective. So you're not going to be tested on angle conversion between decimal degree and degrees, minutes, seconds form. Okay, and you're not going to see this on the homework. You're not going to see it on the quizzes or exams. Okay, and you don't have to do the work for this one. You don't have to turn the work into me for this section or like this objective. Okay, so example 1, you don't have to turn it in at all. Okay, however, you can read it for fun. It's actually mandatory for some other like trick classes, but for my class, I make it optional because for like, to my experience from the last semester, lots and lots of students have difficulty with this section, and it took us forever to figure out like one objective. It took us like 2 hours to finally get like some start of this. That's why, like, just a heads up, it might be a little challenging to read and understand and then do the work for this section. Okay, so if you want, you can read it for fun. Again, you don't have to turn in the work for this page. You don't have to turn in the work for example 1. Okay, that's why I'm not going to mark like a green star on this one. Okay, but just because it's optional, it doesn't mean that you don't have to do it, right? If you do it and you have any questions, still hit me up. Okay, like, ask me your questions. I'll be cool with it. All right, let's talk about the very first official objective of today: how to find the arc length of a circle. So if you recall this picture from the last page, when we talk about the definition of a circle, it's the same thing pretty much, but it has 2 circles in here. And the reason why we have circles is because we have center angle in here. It's not angles anymore. It's a central angle. Central in here is adjective form of center. And center, what do we mean by center, right? In here we talk about center of a circle. That's why we have the circles in here, and that's why we have the name of central angle. Okay, so just imagine we start with a circle in here. Let's talk about the blue circle. It has a center in here, right here. And then let's make it our vertex for the angle. And from there, we draw our first ray. We call it initial ray because it's the first ray. And then we draw another like random ray. We call it the terminal side because it's the second ray. Okay, the gap in between in here is it's not just an angle anymore. It is a central angle. We call it theta. Okay, and just for like some of you guys, my question, how you guys write theta is Theta. It's a Greek letter for angle. Okay. All right, that's the definition of the center angle. Now let's consider a circle. The circle in here, the black circle on the right side, it has the radius. So how can we draw a radius, right? We start from the center and make a random like distant connection or like segment to a point on a circle. We're gonna have the radius. If you don't want it to be in there, you can, let it be in here from the center. We draw it to the point of the circle, and we have the radius. This is also the radius. Okay, all the radii or like the radiuses, like the right term for it will be radii, plural form of radius. But yeah, on the radii they should have the same measurement, right? Because it's like the same distance from the center to any point of the circle. If one of the radii is not the same as the other like radii, then we're not gonna have a circle. It's gonna be like an I don't know, like an ellipse or an oval or something like that. But it's not gonna be a circle anymore. Okay. So now just imagine that these two radii in here are actually rays. Like this is the initial ray and this is the terminal ray. Then the angle that we have in here will be the center angle, right? And if you notice, from one end of a ray to the other end of a ray, we have this curve in here, right? Okay, let me use another color for this one because it's like a mess right now. Okay, yellow is not a good color. Let me do pink. Okay, this is not like better, but you get my idea, right? It's like the red curve in here. This is what we call by the arc length, or S. S for arc length. Okay, what does it mean in here? Like if you zoom it out, it looks like a curvy line, right? It looks like this. Okay, but just imagine if you can pick it up from the air and just stretch it out, it will look like a line, right? Like this. If you were to stretch it out. And because it's a straight line now, you can measure it, right? If you put a ruler next to it, you can read how long it is. Okay? But some lines are like too long or like too short, way too short for a ruler to measure. That's why we come up with this formula in here to measure the arc length. We come up with a formula that says that theta, the angle, equals to S divided by R. Or another like version of this formula, it is S equals to R theta, where you just multiply R through both sides. I usually remember this formula. I don't know why, but I think this is like more useful in the sense that it's easier for you to find the arc length. This formula in here allows you to find the angle, so it helps you to find our theta in here. But this formula in here, it helps you find S, which is the arc length. Okay, and just in case you guys wonder what this is, this is a question mark, like a really bad looking question mark. But yeah, all right. So let's talk about the first example in here. The minute hand of the clock is 4 inches long. How far does the tip of the minute hand move in 20 minutes? So just imagine if you have a clock, it looks like a circle, right? Like this. And you have a center, every circle has a center. And just imagine that the minute hand takes up like the whole radius. I know that this is not true because like most of the clock, the minute hand is shorter than, you know, like half of the diameter, or like shorter than the radius. But, you know, for the sake of the scenario, let's just imagine that the minute hand takes up the whole radius. We know that the radius in here is 4 by the question. Okay. Just imagine this is like 3 on the clock. Like this is 12 and we have like 1 and then 2 and then 3 and then 4 and then so on. Okay. So then if it moves 20 minutes, where it is, right? So this one is like 15 minutes. So we do this is 4, and let's mark out some like angles for like convenience. Okay, let me backtrack a little bit in here. Okay, so this is 4 and this is like 5 and this is like 6 and 7, 8, 9 and 10 and so on, if you want to like notate them all. Okay, let me like circle 20 minutes again. So from 3, the first place that we at, we move 20 minutes. So we do 5 minutes in here, 10 minutes, 15 minutes, and 20 minutes. We'll stop at here. Okay, so this is right here is the initial sign. And for the terminal side, we're going to connect it towards 7. So we have 2 sides in here, or 2 rays in here, and in between, we have an angle. Okay. In order to find the arc length, we can use the second formula. Let me highlight this one, because this one I think is very helpful, very useful in the quizzes, in the tests, you know, like in the assessment, in the homework, and maybe in real life problems. Okay, so in order to figure out the arc length S, we must know R and we must know theta, right? Notice that R is given in the problem is 4, so it's the easy part. But theta, how do we know how much is theta in this picture, right? So we all know that there are 60 minutes in an hour. Okay, so let me just put like 60 minutes in here, and that 60 minutes for an hour, that will take like a whole round, like a whole rotation of the minute hand to go, right? So is corresponding to 360 degrees of a full circle. So now just imagine that we only have like 20 minutes. How much would be in degrees, right? So let's just imagine that we have an X in here or something like that, because we don't have any number for it. We don't know the number for it, right? So now what do? Just imagine there's a fraction sign here, in here, and this arrows in here, they become an equal sign. If that happens, we will do cross multiplication. So we have this cross in here, and we have that cross in there. What does it do? It tells us that we have 60x for the first cross, and the other cross is 360 times 20. If you put it into the calculator, you should get something like 7,200. Okay, and then how can we solve for x? We divide both sides by 60, or like my trick to do like mental math, I guess. We can cross out a 0 in here and in here, so we have 720 divided by 6. So x in here, it equals to, this is like 1 and 2 and then 0, so 120 degrees. Okay, so x in here, it equals to 120 degrees. Okay, so let's put the numbers into the formula right here. So s, the arc length, it equals to r, which is 4, times 120 degrees. I keep telling you guys, make sure you don't drop the unit, okay? If it's in degree, make sure you put a little circle on top of it, just so that I know that the number in here is in degree, okay? However, let's stop in here. This is wrong. Don't do it, okay? Let's look back at the definition earlier for the arc length. If you notice, the angle in here, it has to be in radians. What we have in here is in degrees. Okay, this is like really ugly looking, so I'm not gonna highlight it anymore. But technically, like, this is wrong, right? We cannot do 120 because it's in degrees, not in radians. So how can we convert from degrees to radians? Okay, let me delete some steps in here so that I have space for more steps. Alright. Okay, let me put in another color because this is like another part. Okay, to convert from 120 degrees to radian somehow, let's recall the fact, okay, we don't know what it is, so let's just put it in x. Okay, let's recall the fact that we had earlier in the past slides. I told you guys that this is like a very big, like important information between the relationship between degrees and radians, right? We have to memorize that 120 degrees equals or equivalent to pi radians. So let's copy that into our brain and let's bring it down in here. All right, let's stop in there. Okay, so we have 120 degrees equivalent to pi radian. Okay, if you want to ask me why the first column in degrees and the second column is in radian, I'm going to tell you the order doesn't matter. You can put the radian column first and the degrees column second, but make sure you don't mix up the column. Make sure you don't do like 180 degrees in here, equivalent to pi radian, and you do like x radian in here, and then 120 degrees in here. This is wrong, okay? This is not acceptable because it doesn't go by any column at all, right? Because like this is not like a unique column of degree or radian, and this is same thing. This is not like the same unique column of system. Column of unit. Okay, so let me get this out of like the way before you get it into your head. Alright, so now let's just imagine that you have a fraction here fraction here, and these turn out to be like equal signs. So now we have cross multiplication just like back in the day, and we have this cross and we have that cross. That tells us that 180x equals to 120 pi, and from there to solve for x we're going to divide both sides by 180. At this moment, at this point, I would prefer to keep it as like a fraction. So my tips in here is that you can cross out the zeros in here. Just imagine you like divide each of the numbers in here by 10. You're gonna have like 12 and 18, right? If you input this into the calculator, some calculators might help you like simplify the fraction out. Some other calculators might not do it. It will give you like a decimal version of this or something like that. I would not prefer decimal, okay? And for your information, if you were to put this into your calculator to get like a fraction, like a simplified fraction, make sure you don't input pi into there, okay? Because the calculator will read the pi as 3.14, which is not good, okay? For like the work that you want to show in here. Okay, so let's do it mentally real quick in here. For 12 and 18, 6 can go into there. So 12 divided by 6, we have 2. And then 18 divided by 6, we have 3. And then make sure you rewrite a pi in here because we never like touch it, right? So 2 pi over 3, this is in radian, right? So now that the theta is in radian, we can use the formula again, right? So let me put in another color. Let's do red again. So let's start again. The arc length S equals to the radius 4 times the angle in radian, which is 2 pi divided by 3, equals to 8 pi divided by 3. Okay, so this is the final answer. It could have been the final answer. However, if you look back at the problem, it tells you to round the answer to 2 decimal places, right? So let me like take out the box because this is not the final answer anymore. You have to input into the calculator and get the decimal version of this one. So let me get the calculator really quick and let's see what we have for the decimal version of this. So we will do 8 times 3.14 divided by 3, and that gives us 8.37 because we have to route it to 2 decimal places. And you can box this one, okay? And make sure you don't drop out of units in here because the arc length is in the length unit, so it's not in degrees or radians. It has to be in inches or like centimeter or something like that. Okay, I accidentally crossed it out here. Let me just underline it like this. So the final answer in here is 8.37 inches. Okay, this is my inches in bad writings. Okay, a really quick reminder for you guys before we move on to the next subjective is that make sure you don't make this mistake, okay? I know that it might sound silly to some people, but 4 in here is actually 4 over 1, not 4 over 4, right? Let me put it in like blue or something like that. 4 in here, once again, 4 is 4 over 1, right? Because if you think it as 4 over 4, then 4 over 4 is 1. It's not 4 anymore, right? So once you do multiplication, we will times top by top. That's why we get 8 pi. And then bottom times bottom, that's why we have 3, okay? So this is the right answer. If you were to give me something like 8 pi over 12, just because you think that the bottom is 4, because 4 is 4 over 4 for some reasons, I don't know, and you got me 8 pi over 12, this is wrong, okay? I'm going to cross it out. I'm not going to give you any credit for this one because this is I don't know, like this is shouldn't be a mistake, okay? So make sure you jot it down, make a star in it, or like write something next to it to keep in mind that for fraction multiplication, sometimes if it's like a whole number, you have to write the bottom as 1 so that it's more convenient for your multiplication, okay? And now let's talk about the next objective, how to convert from degrees to radians and vice versa. Okay, we actually did it in the last example Now let me talk in more details on how to do it. Okay, so the very, very important information that we have to memorize, as I told you guys, is that we have to know that pi radians is equals or like equivalent to 180 degrees. Okay, and again, the order, it doesn't matter. You can write pi radian equals to 180 degrees, or 180 degrees equals to pi radians. It really doesn't matter the column. So now let's talk about the first example in here, part A. How do we do it? We have the number negative 270 degrees. So I'm gonna put the negative 270 degrees in the degree column, which is this one in here. It goes like negative 270 degrees in here. And then for the other spot, since we don't have anything to put it there, we're gonna have x in there. And just imagine if you have a fraction here, and an equal sign between. We will do cross multiplication. So let me change it to orange. So we have this cross and that cross. So then we're gonna have something like 180x equals to negative 270 pi. And again, we divide both sides by 180. So the 180s are canceled in here. If you remember my tricks, you can cross out the zeros in here. And if you want to do it like mentally, like me, just think for yourself what number can go into both 18 and 27. And then for me it's 9. So then I'm gonna get something like 9 goes into 27 3 times, 9 goes into 18 2 times. Make sure you copy that sign down. This is negative, so the answer will be negative. And the pi, because we didn't touch it, so let's bring it down here. So this is the word. Okay, these are the word that I expect to see on the assessment. Okay, don't just give me the answers. Don't just write out, oh, negative 270 degrees is negative 3 pi over 2 radians. This is not acceptable as the word. Okay, like I want to see what you do to get to the final answer, not just the final answers. Okay. And similarly, if you want to convert backward from radians to degrees, you're gonna do the same thing. Okay, let me use another color for this one, say pink. Okay, let me do it in here again. Let me take out some work. Okay, let me just erase them all. Okay, this is better. All right. So now let's see. I'm paying for this number. Okay, I hit the point there. For this number in radians in here, since it's in radians, we can put it under the radian column, which is pi radian. So we have 5 pi over 6 in here. If you want, you can write like rad, but I'm running out of space, so I'm not gonna write rad in there. And then for the other spot, since we have like 4 spots in there, right? Like this is the first spot, second spot, the third one, and then this is like the fourth one. We don't have anything to write in there, so we're gonna write x. And let me get the light out before we mistake it for something else. All right, next up, just imagine we have like a fraction bar in here, and between we have the equal sign. So then we're gonna perform cross multiplication again. Okay, let me put it in orange. So we have this cross and that cross. So we have pi x equals to 180 times 5 pi over 6. And once again, 180 is actually 180 over 1. Please don't read it as 180 over 180 because it's wrong. Okay? And in here, if you remember how to cancel them like crossway, 6 go into 18 3 times. So 6 go into 180 30 times. Okay, and then since we have a number in here and also in here, so then we will have pi x equals to 150 pi, and then we can divide both sides by pi, so then we will have x equal to 150. So the final answer in here is x equal to 150 degrees. Okay, I forgot to write the word radians in there and it bothers me, so let me just put back the word radians in there. So again, let me put it in blue. These in here are the final answers. on the assessment, on the homework, if you guys just give me the answers in blue, it's not the work. Okay, they are just answers. It's not the work. What I want from you guys are these. I want you guys to show me how you did to get the final answers, not just the final answer. Okay. Okay, let's talk about the very last part of this example, part C. Assume that the radius of the Earth is 3960 miles. Now we have to find the distance between the two cities. Okay, so this is the globe. We have the globe in there, like right at the bottom of the page. Charleston is 38 north latitude. So we know that up top in here we have 9 degrees. So 38 is about like, like a third of 30. So I would say is right here at the L mark. So let me just put C in here for Charleston. And then Jacksonville in here is 30 degrees. It's like a little tiny bit below 30, right? So, I mean below 38, right? 30 in there. Let me put like J in there. Okay, so if you connect the two cities together in the globes, you will have like the little curve in here. Okay, now let me zoom it out a little bit here. It will look like this, where this one is Charleston and this one in here is Jacksonville. Okay, just imagine that in here you have like 38 degrees and in here you have like 30 degrees. So the difference in the angle in here, it will be 38 minus 30, which is 8 degrees. Okay, so the angle in here is 8 degrees. Now, since they asked me for the arc length, let's recall the formula for the arc length, S equals to R theta. We know that R equals to 3960 already. We know that theta equals to 8 degrees already. So if we put the two numbers together and multiply them, we get the answers. But it's still wrong. Why is it wrong? Because I told you guys, theta cannot be in degrees if you want to use this formula specifically. So with that saying, we have to convert 8 degrees to radians, okay? And how can we do that? We're gonna use the same system that we used before. So let me erase the work in here. Okay. So now let's put 8 degrees in the degrees column right here, and then the other spot we'll put X, and then fraction bar, and then cross multiplication, and then we have 8 pi equals to 180 X. Okay, so now how can we solve for X, right? We're gonna divide both sides by 180, and then okay, let me just like simplify it in here. X equals to something and then pi, right? What is that something? What can go to 8 and 180? I would say 4, okay? 4 goes into 8 2 times. 4 goes into 180, how many times? I would say 45. Okay, please double check the work in here, okay, because you have the calculator, and for the sake of time, I usually do it mentally. Okay, so now that we have the angle in radian system, we have everything to plug back into the formula, right? So the arc length in here, it equals to 3960 times 2 pi over 45. Okay, and if you input it into the calculator, let me get my calculator again real quick. We're gonna get the answer. And since the question doesn't specify how many digits or how many decimals that we have to round in, if you see this situation in the assessment, please keep in mind that just route it to two decimal places. Okay, so let me do 3960 times 2 times 3.14 divided by 45. I got approximately, it's actually not approximately, it is exactly 552.64 miles. This is the final answer. Okay, and here is your turn. Try this one and make sure your turn is a part of your work. Let me put a green star in here so you know that you have to turn it in. Okay. Alright, let's move on to the next objective of the day. How to find the area of a sector of a circle. Okay. So the explanation, the derivation for the formula might be a little bit complicated. Let me remind you guys of two formulas from geometry. The area of a circle is pi r squared, and the circumference of a circle is 2 pi r. Okay, so keep that in mind. So let's consider a circle. The circle in here, it has an angle theta, it has the radius r, and we want to know the area of the red sector in here. How can we do that? Just imagine it as like a pizza, right? Like if you want to take out this line here, then how much proportion of that slide compared to the whole pizza? To me, the slide is like a fourth of a pizza, but we don't know exactly how much it is, right? So how can we do that? We're gonna like use a formula in here. A little bit of explanation is that we like the ancient people, like back in the day, people proved that the ratio of the angle and circumference, it equals to the ratio between the area of the sector to the area of the whole circle. Okay, and since we have two fractions and the equal sign between, we will do cross multiplication, this and that, and then we solve for a, and then we got a, the area of a sector of a circle equals to 1/2 r squared theta. Okay, so this is the second formula that I want you guys to memorize. Okay, this is really ugly, so let me just, nope, here. Okay, so let me highlight like this so that you know that this is the second important formula that you have to keep in mind. If it were to be an assessment, make sure you write that somewhere to prepare for the tests or the quizzes. Okay, and then this is like the second formula, but it's like the first formula of the area, right? So we know that there is a relationship between theta and s, the arc length. Theta equals to s divided by r. So if you want, you can replace this theta in here in the area formula by r, s over r. Okay, and after that we can cancel one of the r's in here with like the r on the bottom, and then we put everything together. We have the area, the second formula for area equals to 1/2 rs. So this is the third formula of the day that I want you guys to memorize. Try to highlight it in a nice way. Okay, so these are the three formulas that you have to memorize to get ready for the quizzes and tests, and even for homework. Okay, so now let's talk about the examples in here. So the examples is asking us to find the area of the sector of the given circles. We know that the radius in here is is 5. We know that r is 5, and an angle in here is 120, so we know that theta equals to 120. But wait, I told you guys that whenever you use one of the three formulas in here, it has to be in radians. Okay, let me highlight that information right here. Theta, it must be in radians, no other option, no other choice. Okay, if you have it in degrees, you out. Okay, like for the angles in these formula, it must be in radians. So if you remember the relationship between radians and degrees, it goes like 180 degrees equivalent or equals to pi radians. And again, so we have like 120 degrees, so we're gonna put it underneath of the degrees column. In here we have no like number for this spot, so let's have an x in there, and just imagine we have a fraction here in here, and these turn out to be like equation, like the equal sign. So then we will do cross multiplication. We will have 120 pi equals to 180x. We did it in the last slide, so shortcut, the answer in here, x equals to 2 pi over 3. Okay, if you want to know why, well, actually in here you can divide everything by 180 and then you simplify the fraction and you're gonna have the answer for x. Okay, since we know r and theta already, let's use this formula in here. Okay, this formula in here is to find the area if you know r and theta. This formula in here is also helps you find area, but it's only helpful when you know the radius and the arc length. Okay, so the difference in here would be, okay, let me circle it in a different color. The difference in here is whether you have the angle or the arc length. Okay, back to the problem. So area in here, okay, so that A, it equals to 1/2 r squared theta, right? So this in here, 1/2 is just 1/2 is a part of the formula. R in here is 5. Let's put like 5 in here, square. And then theta in here is 2 pi divided by 3. And since we have to route our answer to 2 decimal places, so let's put everything in the calculator and get a decimal version of this. So we do 1 divided by 2 times 5 squared times 2 times 3.14 for pi, and then divided by 3. And then the final answer in here, it will be 26.17 because we have to route it to 2 decimal places, okay? And the unit for the area in here is always in units squared. Okay. Okay. And the unit in here is feet, so we're gonna have it in feet square. This is the final answer, so let me just box it in here. And okay, let me highlight the unit in here really quick. Make sure that the arc length is in unit, but in the area it has to be in unit square. Okay, so if it were to be in arc length, it will be feet, and if it were to be in area, it will be feet square. The 2 in here is very important. Make sure you don't drop the 2. Okay, and here is your turn. Make sure you do this example and turn it in as a part of the work. Let me put it in green star, so you know you have to turn it in also. Okay, moving on to next objective, and also the last objective of the day. This is optional, and again, whenever it says optional on any objective, it means that it's not going to be tested. You're not going to see it on the test. You're not going to see it on homework. You can read it for more information, for more like knowledge. Read it for fun. Okay. This in here, like if you major in engineering, I highly recommend reading like this page because it's telling you about the linear speed and angular speed. You're gonna need these for physics classes. Okay, if you have to take this class because it's a prerequisite for physics classes, this is where you have to read. Okay, make sure you read it. Okay, and again, you don't have to turn in a word for this one. If you have any questions on this one, let me know. Email me, text me, and group me. Just let me know. Okay, thank you for listening. Have a great day. Bye bye.